Before we get started, I'm currently creating a 12 to 24 weeks training course on smart contract development, auditing, and blockchain decentralized application automation. It's going to be a comprehensive training course, and mainly it will be a one-on-one section. I'm not taking more than 10 students at a time, and so that I can take you from any level you are in, whether you have written code before or you've never written any code before, and make you into an expert. If you are interested in this training course, please leave your comments below, and once my waiting list page is ready, of course I'll let you guys know. By the way, if you want to integrate blockchain solutions into your business, or you have an idea of a blockchain application and you want me to write that for you, or you just want me to audit your code and take a look at your code base for you, please check the description to this video, book a call directly with me, and I'll take it from there. So as before, let's define let's define the license, the solidity version, and the things we are going to need. We need to import scripts. Of course, when we need to debug, we'll probably need console to log the error. All right. What else? Now I've added a couple of more tools we'll need. Of course, our hyper config for all the parameters we'll need. We'll also need ERC20 interface. Now, these DevOps tools, we'll need these to fetch the most recent deployed um, version of our contract. And I need to install it. That's why it's showing error. Before I do that, let me define the first script we are going to write. It's going to be to transfer token from base to other chains using multi-core handler. So, now let's now install this because that's why it's showing us error. I'm going to come here and start my just bring up my terminal. Then I'm going to clear this. This is the command over here. So this is the command to install the tool, the DevOps tool here. So I'm going to run forge install ciphering foundry DevOps. Yeah, ciphering, you must have heard of ciphering updrafts. Those guys are doing a whole lot. Now I got error because I included no commit there. Now I just did it without no commit, and everything has just been installed. So just run the command without no commit. All right. So yeah, can hide this now. Then the next thing is, let's start. Now what we want to do inside this script is to call this particular function, which is bridge token to other chain with message. But before we do that, we need to fund our contract. You can see this line. It looks for the token we have, the balance of this token in our contract, and transfer it. So that means that we have to do that one first. So I come back here and I'm going to write another script first. This script will be for us to get worth wrapped Ethereum, then we'll send it to our contracts. Now, before we can do this one, we need to get the interface of wrapped Ethereum. Now you can just Google that. So I'm just going to come to this interface and I'm going to create a file to hold our iWorth. That's the interface of the worth token. And I'm going to paste the interface here. Now you feel free to pause the video and get this down. All right, but you can easily Google with wrap the Ethereum interface and you'll get the interface. All right, so yeah, moving on from here, let's get back to this. As you know, once we get the interface, we must also get the contract address. So worth contract address on base sepolia is this, and on arbitrum sepolia is this. I'm just going to come here now and define and import the high worth interface. So just as we did for the deploy scripts, we're just going to come here and define this function run. Whenever we call this contract, this function will run. So we've imported our epa config because we need some values there. Now the DevOps tools we installed earlier, this is it, and we are calling get most recent deployment function on it, so that it will help us get the most recent version, deployed version of our contract from it. So the address is here, then we are passing it into this function. Now I need to define this function now, because that's where we are going to um, get with and also fund our contracts. So this will be public, and we have it here. Now I need to define the missing parameter here. I'm just going to call it underscore. This should be small letter. Now don't forget that Anvil gives us if what 10,000 10,000 units of ETH for us to play with. Now let me show you the interface of worth. There's this function called deposit. This is what we are going to call this deposit function, and when we call it, we'll send an amount of ETH to it. It will receive it, lock it up, and in turn it will give us equivalent amount of wrapped ethereum. So that's how we convert ETH to worth. So let's quickly do that. As before, um, okay, as before, just as we did in the deploy script, we are going to start with vm.start broadcast, and it has to end with stop broadcast. All right, so we are calling our iWorth, and we are calling it with the address of base worth on base. Then we call the deposit function on it, and we transfer an amount of worth to it. So I'm going to come here now and define the worth amount we want to convert. I mean the ETH amount we want to convert to worth. I'm going to call it, this will be a UINT 256, UINT 256 public, and I'm going to call it let's give it 100 times 10 times 10 raised to the power 18. So we are taking 100 out of it and we are converting it to worth. So the next thing is, after this, then it's going to, if it's successful, it's going to log got worth in wallet. Then the next thing is we need to transfer that worth, wrapped worth, we need to transfer it to our contract. So this, it needs to be here. So for me to explain, let me quickly explain this. There's this function on the interface called transfer. It takes where we are transferring it to and how much we are transferring to that point. I mean how much we are transferring to this address. All right. So this is the transfer function we call. Once it's successful, it will tell us worth transferred to base cross-chain caller. If it wasn't successful here, it will tell us, it will revert this error, wrap the ethereum transfer field. Right, that's the essence of this require function. Now let's go to our makefile and define a command to call this. So this is the command. I'm calling it get worth and fund contracts on base. And with this line, is going to go into our script, locate interaction with base contracts file, look for this contract, this script inside it. So you can see the name of the script is get worth and fund contract. Then it's going to now run that script. So if we have done it well, let's try and see and test what we've done so far. Okay, I'm just clearing my terminal. All right, so I'm going to restart the blockchain, make Anvil fork base. As it's running, I'm going to now come here and deploy again. Let me just be sure that it's running. Yes, it's running. I'm going to deploy again. Should Once it has deployed, I am now going to try and fund it and see if we are successful. All right, that's good. So over here, I'm now going to run this command, make get worth. This is this. So I'm trying to fund the contract now. Hopefully everything goes well. All right, we have an error. All right, we're getting the error because of two things. The first thing is here, we're supposed to be importing worth base Sepolia, but what I wrote there was worth Arbitrum Sepolia. So I was using in the epoch config, I was using this address instead of this address. So I've corrected that. The second thing is our TOML file. We needed to add this line just to give access to these files. All right. So once we do that, everything should be fine now. So I'm going to run it again. Come here. I'm going to start our blockchain again. Just waiting for it. All right, it's up and running. Then I'm going to deploy once again. Hopefully everything goes well. All right. So okay, we've deployed successfully. Then we are now going to fund the contracts. Let's see if it goes. We can monitor from here too. Let's see. Oh, it's run already. So you can see we said after this line, get weights in our wallet. We have that logged out. Get weights in my wallet. Weights transferred. So we've been able to fund our contracts. So good. Yeah. So we can now come back here and continue. At this point, please don't forget to like, share, and subscribe to this channel. It takes a whole lot of work to get this video up to you guys. So please encourage me by liking and subscribing and pin the notification bell. Back here, so as before, I'm going to, we need run function. We get the most recent version of our contract, and we're going to call this function. Let me define transfer token from base using multi-core handler function. Yeah, I'm just going to come down here. All right, function is going to be public. All right, then okay, let me use this as parameter because we are passing the address of the most recently deployed version of this. All right, now over here, the first thing we need is our epoch config that will help us a whole lot. Over here, then we need, as before, VM starts broadcast down here. Then we end the broadcast. Now, the function we are interested in calling is this function. So I'm just going to copy it so that it makes it easier for us to follow, to know the parameters we're going to pass in. So this is, I'm going to just paste it here and comment it out. All right. Okay. This is done. And the first thing is this swap message. we will still encode something inside, but for now, I'm going to just pass an empty message in. You can put it as OX or just leave it empty, but I'm just going to put 0x in, 0x. All right, so let's now pass all the parameters here. So over here, I'm going to implement the function down here, and you'd see. So inside this VM starts and stop broadcast, I'm calling our this function. Now this is our contract that imported. Okay, we've not imported our contract, so I'm just going to come to the deploy script. Where's the deploy script? Over here. Then copy this because we need it. That's our contract. I'm going to paste it here. So our contract, I wrapped it around the address of the most recent version of it we've just deployed. Then on it, I'm calling the function. Now we need to define this parameter: the destination chain ID, the recipient, the base sepulchre, yes, worth or address on base sepulchre, and all of this. All right. So let's go to our helper config and define them. I'm going to come here and define those parameters. Input amount is the amount you want to send to Arbitrum from base. So this is 1 times 10 raised to power 16. Then output amount is we have to specify to the bridge, which is across bridge, that this is the amount we want on the other side. Because I've done it before, I know they charge about 3% of the value you are transferring. So that's why I'm doing 96%. So 96% of our input token will get it on the other side. This is the Arbitrum chain ID and base chain ID. All right, so we still have a couple of things to define. I need to define the multi-core handler for Arbitrum. So over here, I'm just going to come down here, then define the multi-core handler for Arbitrum. As before, I'm going to come to the make file and define the command to run. Let me do it here to interact. Okay, should be here actually. Yeah. So this is the command to bridge token from Arbitrum. Okay, this is from Arbitrum. So, as before, I'm going to come to the make file and define the command to bridge token from base to Arbitrum to other chains. So it's going to call our function, the function we've just written, transfer token from base to other chains using multi-core handler. That's this contract, this script we've just written. So then here on the local net, okay. I think we can test now. So I'm going to do Command J to bring up my terminal, then clear it. Alright, then I can now restart the blockchain, make Anvil fork. It's up and running. Then we can now deploy. So over here, okay, here, I'm going to run make deploy to fork base. It's up and running. Now let me try and get worth. Let me hide this. Now I'm going to fund the contract because money has to be in the contract before we can do the bridging. Okay, we've been able to fund the contract. You can see worth transferred to our base contract. Then let's now start the bridging. Make bridge. All right. Hopefully everything goes well. Wow, everything goes well. That's good. So we have our transaction, everything goes well here. Base Sepolia, this is the transaction receipt. All right. So everything has gone well. And let's come back here. I'm going to minimize this. So we've been able to make transfer. Something I forgot here, if you notice, recipient, where recipient is the address on Arbitrum on the destination chain that we are sending the token to. If you notice, I'm using multi-core handler as the recipient. It's because we are going to later send message along with it. So we need to make our recipient multi-core handler. The multi-core handler will receive the token, transfer it to where it's meant to be, and also deliver the message we want it to deliver. All right. So let's move on. Now let's think about the message we are going to send. What we want is that after the token gets to the destination chain, we want to swap the token to another token. So if we have transferred wrapped Ethereum, we want to call Uniswap V3 and swap our wrapped Ethereum to USDC. So to implement that, I'm going to come down here and I'm going to create a new file, no, a new folder rather. I'm going to call it interfaces. Interfaces. Inside it, I am going to put the interface of our contracts. These contracts based to other chains. So these are cross-chain color contracts. I don't know where this one came from now. Okay, don't save. Close please. Alright, so I'll come down here so you can see the functions we can call in an interface. They are all external functions. Then swap on Uniswap V3, then swap on Herodrome V2. These are the functions we can call on the contract. So the next thing, I'm also going to create another folder. I'm going to call it library. Now that means that we are going to create a library. So I'm going to create a library called generate message helper.so library. Now what the work of this library is just going to help us encode the data we send in our message. So libraries are the same thing as contracts. It's just that once you deploy them once, you can use them again and again. All right. So over here, so as before, we need license the solidity version, and I've just imported the interface we've just defined. So this is how you define a library. So you just use library keyword. So this is where we are going to write our code. All right. If you go through the documentation for across protocol, you'd see that for us to encode messages, we need these two structs. We need to define these two structs. The first call is just going to contain this data, the target address we want to call, the message we are sending, and the value. Instruction. So inside the instruction, we'll pass this call in. Then the fallback address is if this call fails, then our token will be sent to this fallback address. So if we cannot swap our token for one reason or the other, our token will be sent to this address so that we don't lose our token. All right, so let's move on. All right, so I'm going to come down here and define the only function we'll have, we'll be calling in this library. So it's going to be generate swap on Uniswap v3 message for multi-core handler. It's going to receive the address of the cross-chain caller on the destination chain, which will be Arbitrum. The token we want to pass into the Uniswap v3, the token we want to get out of Uniswap v3, the pool we want to call, and the address of the pair that we will need to get the price from Chainlink. the token that will come out, address of wrapped Ethereum that will come out of the bridge on the destination chain. So it's more like wrapped Ethereum address on Arbitrum. Then our user address will be the address, our fallback recipient's address. If everything goes bad, our tokens will be sent here. All right. To make it easier for us to understand, I'm just quickly going to make this illustration. So on the destination chain, our token will arrive at the multi-core handler MH. Then MH will send the token to our cross-chain caller contract. Then the cross-chain caller contract. Then the MH will now call swap on Uniswap V3 on these our contracts, and swap will take place on Uniswap V3. So we need to first of all call approve on these are contracts, so that the wrapped Ethereum on this contract will be approved for Uniswap V3 to take it out. So this is how we are going to do the encoding for that. The first thing is we're going to call this low-level function called abi.encode with signature. Signature is the signature of the function we want to call. All right, and it takes address. This is the address we are approving on our cross-chain caller address, and the amount we want Uniswap V3 to take out of our contract, which is this. All right, encode signature is always the name of the function and the parameter it takes. So this is how you write it. The second function we are going to call is swap on Uniswap V3. Here, this function in our contracts. That's all we are calling. In fact, sorry, we don't really need this anymore. So over here, so we are going to also encode swap on Uniswap V3. If you check the function, it takes you in 256. Let me quickly show you here. Swap on Uniswap V3. Then over here, yes, this is the function. Takes you in 256 address, you in 24 and address. All right. So that's what we are encoding. So it takes our output bridge amount, all the amounts that gets into the destination chain. We are going to swap everything now, and I'm logging all these parameters just to be sure that we are passing the right parameters. All right. Finally, based on our cross documentation, we are going to put the two calls we are going to make. So we'll create two position array. The first position will have our approved call data here. The second position will have our swap call data here. All right. Value is 0 because we are not sending any Ethereum with it. We are transferring token wrapped Ethereum, not coin Ethereum. So that's why it's 0. Instructions. So the call we have, then we pass it into instructions. Our fallback address is this user address. User address will be our personal address on the destination chain. So we'll still pass that in when we are calling this. All right. So after everything, we will now encode the instruction and return it. All right. So let's come back here. So this function will just be an helper for us. So let's come here and import our library that we've just written.